What's up, ladies and gentlemen? This is Mr. Richardson coming through you live through the power of the internet. And what we are going to be talking about today is factoring, specifically how we can use the greatest common factor to factor any polynomial. Let's jump right into it. What is factoring? Factoring is kind of related to factors. The process of factoring is to write something as a product. For instance, think about 24. Think about what some of the factors are of 24, meaning the numbers that multiply to 24. Two that I thought about would be 12 and 2. Writing 24 as the product of 12 and 2 would be writing it as its factors. But there's other possibilities. I could have also picked 4 and 6. That would be a way of writing 24 as its factors, or by factoring 24. When we do this process, we're not going to use constants such as 24. We're going to use polynomial terms or variable expressions that are linked together with plus and minus signs. So two definitions for our notes that we should know is, what is standard form? Well, standard form is when the degrees of a polynomial are decreasing from left to right. The word degree is a fancy word for the highest exponent of each term in a polynomial expression. For instance, take a look at this term here, 4x squared. The degree of this term is 2. That is the highest exponent there. If I look at this term, negative 12x, the degree here is 1 because that's the highest exponent, that imaginary 1 there. And this term here, 9, its degree is 0 because really there's an imaginary x to the 0 here. We say this one is in standard form because the degrees decrease from left to right. 2, 1, 0. Now factored form is different. We just learned that when something is in factored form, it's written as a product. So I could take the same expression here, 4x squared minus 12x plus 9, and I could write it in factored form by writing it as a product. When it's written as a product, this expression here is equivalent to this one. They're the same right now. But you might want to wonder, how do I get back and forth from factored form to standard form? Well, to get from factored form here to standard form is actually pretty easy. All you have to do there is FOIL, and I'm sure you're familiar with how to do that. If I do this double distributing process, what I'm going to get is the term above, or the group of terms above, 4x squared minus 12x plus 9. However, the process from going from standard form here to factored form here is more difficult and is something that we're going to discuss in a lot of detail. The first way that we're going to go from this form, standard form, to factored form is by using GCF factoring. And before we can get into how to factor, let's talk about what a GCF is. Well, a greatest common factor is just the largest monomial term that will divide evenly into every term in the expression. And when we go to find the GCF, I like to break it down into two steps. First step is I want to find the GCF of essentially the numbers, or the coefficients. And the second step is I want to find the GCF among the variable terms. To do that, it's always going to be the lowest power of any variable term. Let's take a look at some concrete examples. In number 1, I want to find the GCF of 6x squared plus 10x, and I'm going to again do it in two steps. First step is find the largest number that divides all the coefficients evenly. So I look at 6 and 10 and think, what is the largest number that divides them evenly? That number is 2. Then I look at x squared and x, the variable pieces, and I want to select the lowest power among those variable terms. Well, this one has a power of 2, and this one has a power of 1, so the GCF for the variable terms will be x, making the GCF of this expression 2x. Let's try another one. Here, in example number 2, I want to see what is the GCF of 8x cubed plus 16x squared. Well, for 8 and 16, the largest number that divides them evenly is 8. So for part 1, their GCF will be 8. And for the variable terms, I just want to pick the one with the lowest exponent. I can only choose these two, x cubed and x squared. Which one has the lower exponent? Well, that's x squared, making my GCF 8x squared. Now let's look at the last piece. On the last piece, I have multivariables. I have y and I have z. I want to find the GCF of these two terms. Well, for the numbers, it should be easy. There's an imaginary 1 here and a 5 here. So for the largest number that divides the coefficients of 1 and 5, that's going to be 1. Now I want to see for each of the variable terms. For y to the 7th and y squared, the lowest exponent is y squared, so that will be their GCF. And for z to the 8th and z to the 5th, it will be z to the 5th. So my GCF is 1, y squared, z to the 5th. And technically I don't really even need to write this 1 here. It's the same without it. Let's see if you can try one of these on your own. Find this greatest common factor. Okay, let's see how we did. So what we want to do here is find the GCF of 18 and 10. That GCF is going to be 2. That is the largest number that divides into them evenly. For a to the 5th and a cubed, that GCF is going to be a cubed, making my GCF 2a cubed. Now that we're able to find a greatest common factor, we should be able to do factoring by greatest common factor. If I want to factor a polynomial using the greatest common factor, what I have to do is follow these 2 steps. Step 1 is find the greatest common factor of all the terms. That's what we just practiced on the previous slides, so it shouldn't be all that difficult. After we find the GCF of all terms, what we have to do is divide each term by the greatest common factor. Remembering that when we divide polynomial terms or variable terms at the same base, we're going to subtract the powers. Let's look at an example. I want to factor each of these polynomials using GCF factoring. When I look at the first one, first I want to find the GCF of all terms. Well, the GCF of 10 and 8 is 2. That's the largest number that goes into 10 and 8 evenly. The GCF of x cubed and x squared is the lowest exponent. That's going to be x squared. So my GCF here is 2x squared. What I do is I take my GCF, I put it on the outside, I open a parentheses, I bring down my plus sign, and I leave space for 1, 2 terms because there's 2 terms above, and now we'll divide each term by the GCF. 10x cubed divided by 2x squared is 5x. Now I divide 8x squared by 2x squared. Well, 8 divided by 2 is 4, and x squared divided by x squared is just 1. Anything divided by itself is always 1, so I'm left with just 4. This one is complete. If I want to check my answer, I can just distribute and see that they're equivalent. Let's try number 2. Step 1, find the GCF of all terms. Well, the greatest common factor of 12 and 18 is the largest number that divides them evenly, is 6. Of x to the 5th and x squared is the one with the lower exponent, that's x squared. So my GCF here is 6x squared. Open my parentheses, bring down my minus sign, leave space for 1, 2 terms. Now divide each term by the GCF. 12x to the 5th divided by 6x squared, 12 divided by 6 is 2. X to the 5th divided by x squared, remembering that I'm going to subtract the exponents, I'll get 2x cubed. Now divide 18x squared by 16x squared, and I should get 3. If I want to check my answer, I can just distribute here to see that these are equivalent. Just one is in standard form, one is in factored form. Let's do one more example together. Here I want to find the GCF of 3x to the 4th minus 5x cubed. Well, 3 and 5 don't really have a GCF. Their GCF here is just going to be 1. X to the 4th and x to the 3rd, their GCF will be the smaller exponent, x cubed. So here my GCF will be 1x cubed, or really just x cubed. Dividing each term here, I need to make sure I subtract the exponents. 3x to the 4th divided by x cubed is just 3x. 5x cubed divided by x cubed, the x cubes will cancel. I'll be left with just 5. Let's see if you can try a few of these on your own. Give this first one a shot. Okay, let's see what their GCF is to start. The GCF of 15 and 20 is 5, and of x squared and x cubed, it's always the variable expression with the lowest exponent, it's x squared, making our GCF 5x squared. Open up our parentheses, bring down our plus sign, leave space for the 1, 2 terms we have. 15x squared divided by 5x squared is just 3. 20x cubed divided by 5x squared, well, that's just 4x. Let's try another one. Here I want to find the greatest common factor of 4x squared and 12x. First step, find the GCF. The GCF of 4 and 12 is simply 4. The GCF of x squared and x is the one with the lowest exponent. That will just be x, making our GCF 4x. Now take 4x squared and divide it by 4x. I'll be left with x. 12x divided by 4x, I'll be left with just 3. If I want to check my answer, just distribute. If you distribute here, you'll see that they are equivalent expressions. One last problem and then we'll get you out of here. Here I want to find the greatest common factor of this expression. Okay, the greatest common factor of 60 and 45 is 15. Of x to the 6th and x to the 5th, it's x to the 5th because the power is lower. And of y to the 7th and y squared, it's y squared because the power is lower. Put my GCF on the outside, open parentheses, bring down my minus sign, leave space for two terms. 60 divided by 15 is 4. X to the 6th divided by x to the 5th, subtract the exponents, I get x to the 1st. 7 minus 2 is 5. 45 divided by 15 is going to be 3. X to the 5th divided by x to the 5th would be 1. Anything divided by itself is 1. And y squared divided by y squared is also 1, leaving us here with just 45 divided by 15, or 3. I hope this video here has helped you with your understanding of factoring using the greatest common factor. Hope to see you all next time.